Okay, so today, once again, we want to proceed with the relationship between period, frequency, wavelength, and speed. All right, just want to look at how these measurable properties of waves are related. So let's suppose a wave travels with a speed. So let's suppose a wave travels with a speed v, and then this speed and then a frequency of say an f, and then this wave covers a distance of wavelength, say lambda, in a time interval of t. So where the frequency is the number of waves crossing in a given point. So frequency is basically the number of waves crossing in a given point in 1 second. All right. Per definition, frequency is the number of waves crossing a given point in 1 second. So if in 1 second f waves cross a given point, then the period or the time becomes period is equal to 1 over f. All right, where capital T here represents our period, our f represents our frequency, and that is 1 over f. That's signifying the waves moving across a given point in 1 second. So by definition, the speed of a wave is given by the expression speed is equal to total distance, total distance traveled divided by the total time taken. Okay, so for one complete cycle, the distance traveled is the wavelength. I'm saying it again. For one complete cycle, the distance traveled is the wavelength. Now, lambda represents our wavelength. Okay, so that's our wavelength. And the time taken to travel this distance is called the period, capital T. So the relation is simply by saying that um, since speed is equal to total distance traveled over time, and our total distance traveled in this case represents our wavelength, what we are actually saying is that speed is equal to wavelength over our time. Now we've also established, all right, we've also said that this is equal to wavelength over time. So where v is indicating our speed, we're actually saying that v is equal to wavelength over time, which is now our period. Okay, so wavelength for our distance traveled and the time for our period. All right, but you and I know that we've established that from here, but we've established this already, that time is equal to or period is equal to 1 over frequency. So all we need to do is replace this in the equation we have here. Doing so, we kind of have this is equal to f. Alright, so let me just do it like this. It's equal to 1 over f, like that. And by so doing, we end up having this being equal to lambda f. So yes, our speed now becomes lambda f, where lambda is our wavelength and f becomes our frequency. and v represents our speed, the speed of the wave. So basically, this is the relationship between period, frequency, wavelength, and speed. And this v equals lambda f is what we recall as the wave equation. So let's learn how to apply this wave equation. V equals lambda f, or v equals f lambda. Okay, so now let us consider this example we have here with our relationship we just derived as the wave equation. With this example, we have a preamble saying that the speed of a radio wave is 3.0 times 10 exponent 8 meter per second. And then it says if a radio station broadcasts on a wavelength of 1500 meters, what is the frequency of transmission? So in this case, this question has given us a lot of information already, and we are just to use the information to determine the frequency of transmission. So here, with our solution, what we could say is that our speed is given to us already as 3.0 times 10 exponent 8 meter per second. Then again, our wavelength is provided to us as 1500 meters. So since we are given these two, the question is asking us to find the frequency of transmission. So in this case, all we need to say is that the wavelength or the speed is equal to the wavelength times the frequency. Okay. Yeah, like that. So since we know this, all we have to do is make the frequency the subject. So the frequency now becomes the speed divided by the wavelength. So doing that, we end up having our 3.0 times 10 exponent 8 being divided by 1500. So here our frequency becomes the division of this over that. And if we do our calculation right, we should have a value of say 200,000 hertz. All right. In some books or some could narrow this as to 200 kilohertz. So that is our example number 1. Okay, again, let us consider the second example. It takes 4 crests of wave to cross a given point in 1 second. So if the distance between successive crests is 20 centimeters, calculate A, the frequency, B, the period, C, the wavelength, and D, the velocity of the wave. Now let's see how to go about the solution to this particular example. Okay, so with this particular example, example 2, we are told that we know that the crest is a wave pulse. Okay, so a complete wave consists of a crest and a trough. Hence, the number of complete waves passing a point is equal to the number of crests or trough. So in this point, in this particular example, we were told that it takes or it took 4 crests of wave to cross a given point. So at this point, the number of waves is the number of crests, and that is 4. Okay, so where we are asked A to find the frequency F becomes equal to the number of waves divided by the time taken. So at this point, the number of waves becomes the number of crests. So the number of crests were 4, and the time was in 1 second. So in every second, there are four crests that cross over a given point. So when that happens, you end up having four heads. So four heads become your frequency. So your frequency becomes four hertz. And the B part was asking you to find the period. Okay. And the period capital T is 1 over F. So since the frequency is 4, the period becomes 1 over 4 hertz. And that gives you a total of 0.25 second. Okay. That becomes your period. The C part of the question was asking us to determine the wavelength. So for wavelength, which is lambda, wavelength was given to us as 20 centimeters. All you need to do is change the centimeter to a meter, and 20 centimeters in meters becomes zero point 0.2 meters. It was given to us in the question already. The question was specific to tell us that the if the distance between the successive crests is 20 centimeters, so that distance between the successive crests becomes the wavelength. And then the D part of the question said we are to determine the velocity. So with our wave equation, we have V is equal to lambda f. That is the velocity. Okay. So at this point, our lambda is zero point 0.2 and our frequency is 4. So zero point 0.2 times 4 gives us zero point 0.8 meter per second. That becomes our velocity. Thank you. So let's consider our last example for the day. We are looking at this example, the distance traveled or the distance between the crest and its adjacent throw on a transverse wave is 6.0 centimeters. If 10 cycles of the wave pass a fixed point in 1 second, calculate the speed of the wave. Now let's look at the solution to this particular question and how to attempt it. So now, according to the question, the distance between the crest and its adjacent throw on a transverse wave is 6 centimeters. Okay, so but then we understand that the distance between a crest and another crest is the wavelength. So the distance between a crest and a throw is half the wavelength. So the question is telling us that half of the wavelength is equal to 6.0 centimeters. That is what we have. So if half the wavelength is 6.0 centimeters, it virtually means that the wavelength is equal to twice the 6.0 centimeters, which is equal to 12.0 centimeters. And this value in meters is this value in meters is 1.2 meters. Again, from the preamble to the question, we are told that 10 cycles of wave pass through a fixed point in 1 second. So this cycles tells us that the frequency there is 10. So 10 cycles per second means frequency is 10 hertz. So what the question is asking us to determine the speed, we just use the wave equation V equals to wavelength times frequency. And by so doing, we have 1.2 times 10. And that gives us a value of, say, 1.2, and that gives us a value of 1.2 meter per second. Note that a correction has been made. The 12 centimeter in meter was rather 0.12 meters. Thank you very much. Have a wonderful time. See you another time.